Hi, I'm Dan Olowski, a founder and CTO of Covia Labs, and I'd like to show you working demonstrations of how Covia Technology can greatly accelerate the evolution of the Internet of Everything. Using our technology, developers of new devices and applications are free to introduce creative new products immediately. There's no need to agree on standards, yet new devices and applications will instantly work with all the world's smartphones, tablets, and PCs, as well as with each other. And all such devices instantly become part of a highly secure ecosystem based on simple human relationships. I'm going to demonstrate 3 applications to show the user experience and how the technology all works. These applications are purposely simple because I like the focus to be on the technology, but please note that these technologies have been used to build sophisticated and secure applications used by the Department of Defense over the last 5 years. The main breakthrough is that our technology turns sets of devices into one virtual device. There are 2 parts to the technology. First, there's the connector, which, like a Java VM, executes a common instruction set allowing the same application code to run on each device. But it goes way beyond Java. The connector exposes the unique capabilities of each device and allows our applications to securely extend their execution across selected devices. The second part of our technology is a new, smarter type of cross-device application that runs on these connectors, which we call connected applications. Connected applications are just like conventional multi-threaded applications, except they know how to distribute their threads to run across selected devices and then run with one event-driven runtime as if they were one application running on one device with direct access to all the devices' combined resources. As you can see in the diagram, the connector is an ordinary native Layer 7 application that's easily ported to each device. The connector only needs to be installed once to make a device forever discoverable from all other connected devices. It can be installed as part of any application or placed on the device as part of the OS or embedded in a cheap, low-end communications chip in devices such as the toy pig that I'll be showing in the last demo. The first application I'll show is our slideshow application. At the start, I have 4 devices with 4 different OSs and 2 different wireless protocols. What's important to understand is that at the start, while there's a connector on each device, the slideshow application is only on the phone. There is no slideshow application or slideshow service running on any of the target devices. When I start the slideshow on the phone, I'll see a list of 3 nearby devices. After selecting devices from the list, the slideshow appears on the device's screens. And then, when I add slides on any device from the gallery or by taking pictures, they show up on all the devices. If I sequence the slides on any of the devices, they change together across all the devices. So note that there was no need to install slideshow applications or services on the target devices. There was no need to know what OSs or protocols were being used. A teenager in his bedroom could have programmed a slideshow and could have spread the slideshow from his phone to my TV with no setup. Also note that there was no need to enter passwords or perform pairing. The reason is that these devices previously learned that they were my trusted personal devices by way of a new security model based on simple human relationships, which I'll demonstrate in the next demo. So here is how slideshow works. When the slideshow starts up, it calls the connector it's running on with a pointer to an inspection thread that's part of the application and directs the connector to run the inspection thread on all the nearby devices it can discover. In this case, the connector is using both Bluetooth discovery and zeroconf to find nearby devices. The inspection thread is set to run on each device and collects information from the connector about the display capabilities of the device it's running on. If the device has a display that's suitable for the slideshow to use, It sends back the device name, icon, and preferred resolution. This information is used to put up a list of compatible devices on the phone screen. After I selected each device from the list, a slideshow UI thread is set to run on each device. When I selected a picture on any device, the application generates an Add Picture event, which is automatically synchronized across all the threads running on all the devices. Each device adds the picture, and we see it on the screen. When I change slides on any device, a Show This Slide event is generated, which is serialized and synchronized across the devices. These events are specific to the slideshow. Because code from the same linked binary is running on all the devices, they all know what these events mean, even though this knowledge only started on the phone. The point here is that no standard is needed for any of the slideshow commands or functions. The application is only talking to itself. If the format of an event changes, or I add a feature in a later version, the new code is automatically distributed. This not only eliminates the need for standards and the need to pre-install services across devices, but it also puts an end to versioning issues. As promised, I'll now talk about our consumer-friendly security model, which is based on human relationships. I'm now going to start a Pong game on a friend's iPhone. Just like before, the game sends an inspection thread to run on the TV and sends back information about the TV, which then appears on a list on my phone screen. This time, when I selected the TV, a security dialog popped up on the TV. This is because the TV has never run any connected application from my friend's iPhone. The dialog asks the user of the TV about their relationship to the owner of the iPhone. When I select Friend using the TV remote, the TV stores access rights for any applications coming from this particular phone. Friend access rights include being able to show things on the screen and use the device's controls, but they do not include the ability to access private photos or any other private information. The Pong game was allowed to run because all the access rights signed into it are now allowed on the TV. If I later run slideshow from my friend's iPhone to the TV, no dialog will pop up because the TV already knows the iPhone is a friend's. Next, I want to talk about discovering and accessing control panels directly from the devices around you. In this demo, I start up the remote connected application that comes with every device on which the connector is installed and that has a UI. The exact same binary remote control app can be run on any connected device. Like before, when I start remote, an inspection procedure is set to run on all the discoverable devices. But this time it enumerates the remote control connected applications on each device, and I see a list of all the available remote controls. If I select Pig's Flight Control, I will immediately see the Pig Control Panel UI pop up on my screen. When I press the Fly button, the pig starts flapping its wings. When I selected the Pig Flight Control Panel, Remote fetched the control panel from the pig and ran it on the phone, displacing the remote's own UI. Then, when I pressed Fly, the UI of the thread of the pig's control panel generated the flap wings event, which causes the hardware control thread running on the pig to call the connector's OEM-specific interface that was created as part of the port of the connector to run on the pig. So here we are showing that any device manufacturer can introduce a new device, such as a toy pig, and know that it will work with other manufacturers' devices without the need to get agreement on any standards or write and install any applications for the controlling devices. Also note that the connector on the pig is running on a low-end Bluetooth chip, yet it's as powerful as all the devices around them. This is because the applications in its ROM can always be fetched and run from other devices. We have all heard about all the great applications for the Internet of Everything, but we think the most important applications have yet to be imagined. Covia Technology sets developers free to introduce a nearly unlimited range of applications and devices for the Internet of Everything, allowing it to evolve quickly. So to sum up, Covia has disruptive technology which can fuel the Internet of Everything. We have 13 blocking patents, and the technology is now available for licensing. We are happy to meet with you and go into much greater detail on how all this works and the benefits for consumers, and in particular for your company. Feel free to pass on this video link to others you feel might be interested. Thanks.